Hello, everybody. Bonjour à tous. Welcome to this webinar on system design with NS-1. Well, so this webinar is introduction in system design with NS-1. So NS-1 is our prediction software. So it will be a mix of a presentation, and we also try to go with exercises together. So if you have any question, please go. There is a Q&A page that is available. And Stéphane, who speaks both French and English, will be our interpreter. So he could interrupt me and he will be able to ask the question, and I will answer the question live. So feel free to stop. Feel free to use the Q&A.
Sorry,
Yes.
Nicolas, with also the chat session if they've got some information to add.
Absolutely. So there is also a chat session. So by using the chat sessions, you also can write comments, and maybe other people can also react and say things about the topics. So first of all, important, I send you a link. So on the first page, and I send you also a link, but I can do it now again. If you have your computer connected to internet, I think it's the case. Otherwise, you will not be able to see the webinar. Feel free to download NS-1 software, and so that we can do the exercise together. Right, Stéphane, ready to start? Okay, so let's start and share my computer with you guys. So currently, what is NS-1? So NS-1 is our prediction software. This is based on a Windows platform, and you can download it for free going on the NEXO website. What does NS-1 do? It does a calculation regarding coverage using NEXO speakers, and it makes you different mappings. So it gives you, different mappings, one in a direct SPL, and also you can visualize SPL distribution, but this is very much related on direction and also calculation of delay. Okay, so nothing about reverberant field. So if you want to know more about reverberant field, you need to have more complicated softwares like the EASE software. And this is not covered in this session. So we will cover the session only with the NS-1. So NS-1 typically is organized in a workflow of 3 different steps. We have the first step, which is the venue geometry creation. So once again, NS-1 deals only with direction. So what we have to do is simply build the audience areas, okay? We don't have to build any complicated reflective surface or anything about walls or anything, because we don't simulate the reflection of the reverberance. The only thing that we visualize is direct sound. So when we have to deal with venue geometry, it's audience areas. If we had to give more information regarding like a screen or a stage, we can if we want, but we don't have to draw everything. So once you okay with entering the venue geometry, the next step will be designing the system. So this is step 2. So what is designing the system? Is to get the good speakers at the good location, and then to adjust the acoustic parameters, like, you know, the horn, if it's a point source, like also the splay angle, if it's a line source. So designing the system is how we can manage all the different settings regarding acoustic parameters and also regarding mechanical parameters. And when everything is set up on this designing windows, then you move to the step 3, and step 3 is running calculation. So when you go to step 3, that we will visualize in the screen is all the direct SPL calculated on the different audience area. So just having a look at this coverage, sometimes you will be happy at the very first time, or you think, I can maybe do it better. So then you have to go back to step 2, change your acoustic parameters, and then go to step 3. So finally, this is like going back and forth between 2 and 3. So you set up in 2, visualize 3, then go back, and so on. So we will divide our training session in 3 different parts. The first one will be dedicated to how we can get a venue inside the software. And then we'll move to the second part, which is designing the system. So let's go first with entering a venue. How can you enter a venue in NS-1? So there are currently 3 different ways of having this audience area inside the software. The first one is to use the internal tools that you can that you access inside the softwares. Okay, so you can draw by yourself surfaces inside the softwares. So the name of these tools are polygons and quadrangles. For this session, so this will be exclusively based on these tools, so polygon and quadrangle. Okay. From time to time, when the venue is a little bit complex, and also because you also get information from other people who work on the project, like, for example, CAD files, or it could be also SketchUp files. So SketchUp is a software for drawing venues, whatever you want. But also his software, you can also get these files and then export them and import them into the NS-1. Okay, so these parts of the software is shown in the level 2 of our webinars. Okay, so I will not explain how to do that on this webinar because it's too short in time. But if you apply to the other webinar, then we explain how to get these files coming from one CAD software to NS-1. I must say that this is not really straightforward. And the main reason why it's not really straightforward is sometimes there are so many details and there are so many informations on the CAD and CAD files that you have to spend a lot of time just by removing all the information that you don't need. Okay, so you have to delete many surfaces. This is why what we used to practice a lot at NEXO is this way of proceeding, is to only get the drawing of your audience with JPEG or PDF files. So if you have a cut view or a top view of the venue, and if you also have the scale of a venue, then it's very easy just to draw by with your mouse, just to draw the surface above the drawing. Okay, it's very much similar to layers, you know, in Photoshop. In Photoshop, you have one layer and you can put another layer on the top of the first layer. And then with transparency, it's very easy and very fast just to draw the audience area on the top above this drawing. So this will be explained in the level 2 of NS-1, and we will not explain that on the level 1, but I just wanted to mention so that you know that it's possible using the software. Right. So basically, this is what I'd like you to draw very first. So this will be our first exercise, but to do this exercise, I need to maybe explain how we can draw and how we can use the tools inside the software. So
Nicolas,
yes.
Sorry to interrupt. Regarding what you just said about round 1 of NS-1, there is some question about when will be the round 2.
So round 2 is not written round 2, but it's written on the list that you get is application case, okay? So application case, I think, correct me if I'm wrong or not, Stefan, I don't know, or case study, I think it's case study. So we have case study.
Performing art
Yes.
venue, is that one?
Performing art venue or also the stadium. So we will explain how we get, because when you go to performance arts or stadium, most of the time the geometry of the venue is a little bit more complex. So we'll show you how we get and we will explain how we get the geometry in the NS-1. Okay.
Next one will be on Thursday this week.
Yes, I think.
Yeah.
Okay, let's open the NS-1 together. Right. So at the very first launch of a software, you always start with this drawing, okay? But to be honest, what we need now is to start from scratch. So starting from scratch is quite easy. It's just clicking File and then select New. Okay, so when you select the new file, you will see that on the left part of the screen, you have your 3D page. So currently this is absolutely empty, but maybe there is something that you can notice in the center of the screen is that you have axis. And the axis is also represented on the left part of the screen. And as you will see here, the red colors is for the X axis, the green is for the Y axis, and the blue is for the Z axis, okay? So we have a convention at NEXO is that we use X for the depth of a room, okay? So X will be the depth of the room, Y will be the width of the room, and Z will be the height of the room. On the right side, you have your list. So this is the list of the equipment. So you can make it shorter, smaller, just by resizing if you want. So if you need more space, then put the list as small as possible. And what you see also on the right part is what is the current systems available. So what you visualize here is all systems. But if you double click on this one, then you can filter the speaker list appearance. So what you see here is currently available only. If I double click again, what I can see is the discontinued systems only. So these are the old systems. And if I double click again, then I can access to all the systems. So make sure that these settings is properly set in your screen. So shown are all systems, because otherwise maybe you will not be able to see all the speaker lists on the right side. One good thing also to start is to check your options. So by default, this is in meter, but as I know that we have also customers from the US, if you want to switch the units from meter to feet, so you just have to click and select feet in that case. So you can do it at the very beginning of the project, or between the project, or at the end in the project, because if convert checkbox is selected, then it will convert meters to feet. So in my case, I will feel more comfortable using meters, so I will check the meters units first. Next options is the edit air absorptions. Edit air absorptions, you need to make sure that the temperatures and humidity is set to very close to your current air conditions. The reasons for that is, as you may know, temperatures will affect the speed of sound. So in the delay calculation, this will change the delay calculation just by changing the temperatures. But temperatures and humidity also will affect the air absorptions. So we have air absorptions calculation, which is managed by the software. So it's always very good to make this value as close as possible so that the air absorptions model is close to the real condition that you have on your field. So currently, Stéphane, I would say we are a little bit lucky because currently in France, weather is not so bad. We are around 20 degrees. So this is what I have today, around a little bit less. Huh? It's 15, 16 degrees. So yeah, let's go to 16. And humidity is more 40 degrees, 40%, sorry. Okay, next one is the desktop colors. So if you prefer having, so we have a light mode and night mode. So if you prefer the night mode, then you can go and using the dark page. I prefer the light one, so I will use the light one. And then the next one is checking for updates. So if you want to check if your system is up to date or pas, so you just have to click on the internet. So you see that currently my versions is okay. And I can download if I want using that window. And the last one also, which is important, is author. So your project by default is signed by your name. And this name is always written on the project that you have to manage. From time to time, you receive a project for other people and you look at what's implementing in the NS-1. If you want to change the design, every time you will have to save a project, you will get a message that says, if you save it, then you will change the name. Okay, so you cannot change any project and not sign the project with your own name. Okay, so make sure that this author is properly set up. Very good. So we are now ready to begin. And I would like to show you how we can build and how we can design venues inside the software. So to design a venue, I just have to click on venue. And then you can see that I have two different options available. The first one is quadrangle and the other one is polygons. So let's start with the first one. So this is a quadrangle. So what you see in this window, first, you can give a name to this venue. You can also select the different kind of audience. So currently the choice is seated. So seated means that the listening height will be 1.2 meters. And if you go to standing, then it will go to 1.6. Okay, so depending if you have chairs on the rooms or if it's a standing area, so you will have to select the kind of audience. When you go to surface, calculation is done on a surface. So this can be useful, for example, if you want to see the behaviors of the rejection, for example, of your system on a wall. So you can create a fake wall if you want, or a fake surface, and activate surface and see how much SPL is given on that surface. And the last one is no audience. Yes.
Sorry, it's my question. Just to know more about this software. Can you move an audience from surface to seated or something after all? Or no?
Yeah, so absolutely. So every time, if you want to change any surface, you can do it at the very first time or after if you want. So every surface can be open and then you can change the audience properties after. So no problem.
Thank you.
So audience means that there will be no calculation. So for example, if you want to be like, you know, a fake screen or anyone just for visual and calculate nothing. So you have to select this one. And disable means that you will not display you will not make visible the surface on the drawing. So in my case, let's start very quickly. Let's go with standing. And then you know what? Let's say okay and have a look on what happened on the screen. So this is basically my quadrangle. Okay, only 4 points. I can use my mouse and rotate the surface. If I use the scroll of the mouse, I can zoom in and zoom out. Okay, and if I press the scroll button, I can pan the also surface. If you don't have any scroll available with the mouse, simply press the Shift key and you can move left, right, and top and bottom your surface. And if you have a trackpad also, by scrolling up with 2 fingers, you can zoom in and scrolling down, you zoom out. Okay, so you know what? I'm going to put that surface on one part of my window. So zoom a little bit. And then I will edit this surface on the other part. So let's try to change the size. So if I want to make it wider, you know, I can currently change this value. So this is 20, but if I want to go to 25, I just have to click 25, and you can see that I make now the surface wider. If I want to increase the depth, I can change the value, and you will see that I will increase the depth of my surface. So size is width and depth. I can make it trapezoidal if I want. Okay, so this is a trapezoidal thing. And if I want now, I can also move that surface. So from time to time, I need to move it, for example, along the depth. So if I move it along the depth, I can change the value here by 5, and it will be moved by 5 meters along X. I can also, if I want, move it on the left or on the right. Okay, let's go 5 meters on the left. And if I want, I can also change the height of the surface by increasing by 5 also if I want. And then I change the height of the surface by 5 meters. So positions is for moving the surface. Then we have also inclination and orientation. So if I, for any reasons, I want to change the height of the last row of a surface, then I can create a slope by just changing the height value. For example, let's go 3 meters, and it will raise the surface by 3 meters at the back. Okay, only at the back. Let me do it again. Let's go 5. Okay, so you see it goes higher and higher. If I want, I can also rotate the surface. Let's go 50 degrees on one side. Then you see that now I have rotated my surface by 50 degrees.
Okay. Sorry, Nicolas, just 2 more questions. I guess there is no difference between apply and OK?
Yes, so when you click apply, it will apply the settings to the drawing. If you click, but the window will kept open. We kept open. Okay, so the venue, the window is still open. If I press OK, then it will close the window. So I will have to double click again on the surface to make the window appear again. So apply is a good way just to visualize what you did on the drawing, but you can also press the enter key on the keyboard. It does the same. Okay.
Another question, as you might know, is there a project on our roadmap to make a Mac version, iOS version of the software?
So currently this is Windows based, and NS-1 will keep Windows based. Okay, so if you want to run it on a Mac, the trick is to get a virtual machine available. So like in my case, this is Parallel Desktop. You can use also VirtualBox. Okay, so VirtualBox is free, so this is great. Parallel you have to pay. And another tool which is free is called Wine. So Wine is also very useful just to get this software running on the Mac versions. Okay. Okay, so let's carry on, guys. So we have our surface here. So this is a 4-point, but from time to time we know that a quadrangle is not enough, because we have more complex surfaces. When I say more complex surfaces, I mean, for example, it can be another part of the room that I have to draw, and I can make a door, I can make anything I want. So in that case, I cannot use quadrangle tools because I need more than 4 points. And I will use polygons. So polygons, to make this surface polygons, I can do a right click and edit this surface as a polygon. Okay, so what is the difference now? If I open the surface, you see that the window is different. So what you see on the window is a table. And in this table, you can see that we have currently 4 points. And what you visualize here are the coordinates. So you can do exactly the same just by entering coordinates of the different points and make any shape available. So in that case, we have 4, but if I want to have more than 4 vertex, I can click on add and have more than 4 vertex. And what we see now on this drawing, if I press this little icon on the top, I will be able to visualize the different points that is inside my surface. And what is most interesting now is I also can take the points and create any different shape. Okay, so if I want to do something like that, for example, up. And this is a surface with more than 4 points. So graphically, you can do like a craft, not a craft, but a draft drawing of your venue just by clicking and moving the point with your mouse. And then you can edit the coordinates with accurate value by opening the polygons tabs. So you see in that case, P5 is probably 40 and not 39. This one is probably 24. This one is also 24. And this one is 20.6. And this one is 12.5. Anyway, so you see, currently we have 2 way of proceeding, quadrangle or polygons. Okay, so up to you to decide what is the best for you, what is the most useful. Some people prefer quadrangle, some people prefer working with coordinates. So it's up to you just to decide what you prefer. So you know what? I'm going to delete everything and start the exercise with you guys. So can we do and work on that project? So we have a project. This is a theaters. And currently I'd like to draw this theater review. So this is what we have. So we have this part of the audience, which is a square of 20 meters depth by 20 meters width. And this will be standing area. So I want the people to be standing here. Then at the back of the audience, we have this seated area. So this is a seated area. The depth is 10 meters. The width is still 20 meters. And the height, the inclination of this area is 2 meters. Okay, so 2 meters for the inclination. And then I'd like also you to draw the stage. So why I want to see the stage? I want to see the stage because I need to visualize what will be the positions of my systems left and right. And also I want to visualize the positions for my front field if I need any front field. And the other things also is that I'd like to visualize the rejections of my design on the stage. So I'd like you to draw this stage, and this stage is 12 meters width, 6 meters depth, and the height of the stage is 1.2 meters. Okay.
If people prefer to stay in inches, that's not a problem for the exercise.
No, if they want to, so they can start in meters and then convert in inch or do everything in inch, no problem. One more thing. I don't want to get in the surface when I want to make the calculation is the surface of the stage. So it's not a seated area, it's not a standing area, this is surface. So I want to specify surface for the calculation on the stage. Right, so let's try to do it together. So currently what we see in this drawing is the audience is made of 3 different quadrangles. So we can use the quadrangle tools to build this venue. So let's have a look together. So I will go back to my software. Right, so I will start by drawing the square of 20 by 20. So I use venue, quadrangles, and change the size. So 20 is the width and 20 is the depth. And we also said that this audience is a standing area. So I put standing and give a name up, and then click OK. So this is my square. Okay. So I will add a new quadrangle, and this new quadrangle will be the seated area. So you see, by default, something has been created in the surface, but I need to change the size, and I need also to change the positions. So let's give a name. So this is the seats, and the audience height is seated in that case. And you can visualize here when you switch from standing to seated that now the color is green. I need to change the size. So if you remember, it was a 20 meters width, but only 10 meters for the depth. Okay. And if you look now, you can see that this is the current positions of the seated area. So I need to move back this surface so that it connects to the back of the square. So I need to move the positions, and currently this is 4 meters from the origin, and I want to move it back up to 20 meters. Okay, so I will go and write 20. So now you can see this is the positions of a seated area. And if you remember what we said that we also need to give a value for inclination. And the value for inclination, I think it was 2 meters. Stefan, you remember what was the value? Was it 2?
2, yes.
Okay. So this is 2. So I create the inclination. So I have my seated area, standing area, and I don't have to close a window if I want to create the stage. No, I can directly press the new buttons at the bottom part, and then you will see instantly that a new surface has been created in the drawing. So I need to resize it. So this is my stage. So my stage is 6 meters. No, it's 12 meters, sorry, for the width. This is 6 meters for the depth. Okay, I will give a name, which is stage. I need also to change because I want to draw it and get a calculation on the surface. So I can select surface. I need also to change the height because the height of the stage is 1.2 meters. So I will go 1.2. And then I need to change the positions, okay? So it's just before the origin. So I need to go -6. So currently you see this is my stage. And there is still something which is wrong in my stage is we can see that there is a value for inclination, okay? And there is no inclination on the stage. The stage is totally flat. So I will move the value here to 0 and then apply, okay? So height is 1.2. Sorry, I think I forget. I put 1.2 on height, but it was 0. And validate, and this is my drawing. So currently what you see here is the theaters. Okay, so please save a project, okay, because we need that project just to do our sound design now. So go File, Save, and I will save it on my desktop. So this is NS-1.
Sorry, Nicolas,
Yes.
that is not supposed to be 2 meters at the end of the theater instead of 1.2, or
1.2 is the height of the stage.
Is the height of the stage?
Yes.
Okay, sorry.
Okay, let's look at the drawing again. Okay, so 2 meters is the inclination, and 1.2 meter is the height of the stage. Okay.
Hmm?
Right. So now let's try to get our systems inside. So to get the cabinet. So we will move now to step 2. So step 2 is for designing system. So before we go into explanation about how to get the speakers inside the software, I would like just maybe to remind you some things about how to choose the speakers. So if you're very familiar with the NEXO speakers, then you can go very fast and very quick. If you are not very familiar with the NEXO speakers, a very quick way, an easy way just to keep organized and to exactly understand what kind of speakers can do is to only get a look at these 3 main technical specifications. So what are these 3 main technical specifications? The first one is the maximum SPL that a speaker can provide. Okay, so the maximum SPL is a combination of speaker sensitivity and amplifier. So for example, in the case of ID24, you can access to that value. And the maximum value is this one, and peak SPL level is 126 dB peak. Then other important information is the frequency range. So why do we need that frequency range? Because if you know the frequency range, you know definitely if it could be used for speech only, or if you want to use it for music, if you need to add any subwoofer. So in the case of ID24, this is only 4 inches driver, we can see that the crossover, so the frequency range, plus minus 6 dB, start from 95 up to 20 kilohertz. And then the last one is the coverage. So why do we need the coverage? Because coverage gives you the way that the kind of radiation that is provided by the speakers. So now let me show you how you can access to that value, how you can manage these different settings in your NS-1. So let's go back to our system and go back to our NS-1. So when you want to get speakers inside your project, you just have to click and select the speakers on the right side and just drag and drops. Okay, so when you drag and drops a point source, for example, so let's start with point source, you will see that it will open the windows of a cabinet. So we can access to the positions of the speakers, and we can also give a name to the speakers. We have also access to rotation angles, so vertical and horizontal plane, and also of a few settings regarding electronics. But the most important for you is this part, is the speaker tab. Because when you go to speaker tab, you can change the arrangement of the speakers, going horizontal or vertical, but you can also change the waveguide. Okay, so remember, waveguide orientation give you the coverage of your systems. Okay, go back to presentation again. Right, so this is from the technical part, but as a system designer, you also have to look at the speaker radiation properties. So speaker radiation properties, currently if we want to make it very easy, we can divide the speaker range in 3 categories. The first one is what we call the point sources. The second one is line sources, and the third one is subwoofer. So subwoofer is a little bit special because subwoofer by default is very much similar to a point source. But if you build a line of subwoofer, and if you keep a space between the subs, which is a maximum of alpha wavelengths, then your line of subwoofer is becoming a line source. So subwoofer can be a mix of point source and line source. By default, this is a point source, but it can be a line source very easily. We will not cover the subwoofer topic in this webinar. We have a webinar dedicated to subwoofer later. So,
Nicolas?
yes.
Yes, sorry to interrupt again. I have two questions. One from Paul. Does peak really mean peak or max RMS?
So, question from does peak means peak or max RMS? This is peak. This is not a max RMS. This is peak.
Okay, another one. Is there a good way to measure slopes or inclination in real life? I often have the situation that I come to theater where the real wall is closed. It's closed, so there is no chance to measure down to the bottom of the tribune or terrace.
Yeah, so you're right. So from time to time, it's not easy. So it's not easy to get this measurement available. So currently, what we recommend for this kind of measurement is to get the inclinometers available. You know, we have laser with inclinometers, and when you get the inclinometers, you have a menu on the lasers that when knowing the slopes where knowing the angles, then it will give you access to the horizontal and vertical plane of a triangle. Okay, it's like I think you remember this sinus and cosinus formula. So we have some laser that can make it available just by reading on it. On the NS-1, there is nothing regarding the angles. Okay, I can show you maybe something that you can use, but let me show that. If you have a chance, to get, sorry, let me do this one, edit as polygon. So this is in the polygon menu. So if you have a chance to get this device, which is a rangefinder device, you can connect these devices in a Bluetooth to NS-1, and then just by clicking directly with this rangefinder device, it will give you the coordinates of these of the points that you are targeting. So this is very convenient, but it's also a quite expensive tool. So this rangefinder is a little bit expensive. And you need to also must be very careful when doing the measurement that you are not moving. So what we recommend in that case is to use a stand for the rangefinder device and then select click, and this will be filled directly into the software. So we have a question from Guillaume that asks, we'll be able to get this presentation at the end. So we'll see how we can manage to maybe to send you a PDF at the end of the webinar. Go back to this presentation because I need to look at the time. So very quickly on how we can go with the systems, point source solution. So what we need to remember by using point source is that point source is always limited in SPL. So don't expect to get very long throw with the point source. The main reasons for that is, as you may remember, if you attend the acoustic fundamentals, the wavefront that is generated by a point source is a sphere. So we have expansion on the horizontal plane and also on the vertical, and the decreasing of the level is -6 dB per doubling distance. So don't expect to have a very big throw with the point source. And the other thing is don't try to make arrays of point source, because if you make arrays of point source, then you will go into interferences, okay? So this is what we need to keep in mind by using point source. And this is also why most of the time when we use point source, we love a point source when we go to non-intrusive sound system design. So for example, in small theaters or clubs and bars, you know, when we don't want to see the speakers. And we also are very pleased to use this point source when we go into system when we have to create advanced sound field, like multi-channels application, like Dolby, like the new AFC4 also by Yamaha. So in that case, the point source are very useful for us. So in your situation, so for the exercise, you will have different point source available at NEXO. So we have the smallest cabinets currently, which is the ID24. So ID24, if you look, is quite powerful. It's 126 peak SPL. This is a bandwidth starting from 95 to 20 kilohertz. And what is interesting in this series is it comes with different coverage options. So this coverage option is 120 by 60, can be 120 by 40, 90 by 40, or 60 by 60, okay? And be careful because this horn can be rotated. So this is a rotatable horn. So regarding the positions of your speakers inside, you will be able to rotate the horn and to give different coverage patterns in your project. So
From the back
ID24 is the smallest cabinet. Yes, Stefan.
yeah, from the back without any tool
Yes. Good to mention, absolutely. So you don't need any screwdriver, you don't need anything. You just have to turn the knob at the back of the ID series just to rotate the horn. If you want also using points, so these are examples of a different application. Front field is very good, but also main system for small corporate event or small places are also very nice with the subwoofer. We still have our PS products. So PS, these point source from a long time now. So we have PS8, PS10, PS15. And what you need to remember with the PS series is that PS comes with asymmetrical horn. So what is asymmetrical horn? It's a horn that provides 100 degrees at the bottom part of the horn and move progressively to 50 degrees when you go to the top part of the horn. So by using asymmetrical horn, you can combine wide coverage for the very first rows and narrow coverage and bigger throw from the other seats, the back seats of the room. And you also can use, so these are examples. So once again, PS can be used as a front house or a monitor or monitors. And we also have our brand new P series. So this is a point source solution. So P series is coaxial speakers. So we start from P8 up to P12. So P8, P10, P12. So you can see and visualize the different peak SPL available. So they are louder than the PS series. They are coaxial. And the other benefits also is that they comes with different options for the horns. So for example, P12 come by default as a 60 by 60, but you can expand the coverage of the P12 by using optional horn, which are magnetics. So you don't have any tools just to open the grill, you don't have any screwdriver just to remove the horn. So this is a magnet, and you put the magnet and you put the horn on the HF driver, and you can access to 90 degrees by 40 degrees, or you can also get the asymmetrical driver, the same as we have on the PS. So P12 comes with 60 by 60, P10 with 100 by 100, which can be changed to 110 by 60, and the same for P8. So for you guys, yes, Stefan.
So I have a request, which was a kind of general request about those new products are for sure available with a new version of NS-1. That's why you need to have the latest version of NS-1 to be able to project those new products. But
thank you for mentioning. You're absolutely right, Stefan. The reasons why also we have to update NS-1 from time to time is because we have these new products available in the new versions. So let me show you for you how you have to manage these things on the NS-1. If I, for example, if I take a P12 and put the P12, you see that I can visualize. So a convenient way to see how the coverage is to make this, to rotate the speakers inside the window and to change the different value. So you see if I run this one 60, 100 degrees. So this is the asymmetrical horn. Okay, I can make it different if I want. Okay, you can rotate. And you can also change to 60 by 60. So this is the windows when you have to specify and to change this coverage. You have exactly the same with the ID24, okay, and you can change the different waveguide orientation and for the PS as well.
For integration, Nicolas, what could be very interesting in terms of point source, because you are in this subject, is that ID24 is in 16 ohms.
Yes, you're
cabinet.
right. Thank you for mentioning that. So ID24 is 16 ohms. So it means that we can get a bunch of speakers on one channels. So this is absolutely very convenient, you're right. So the exercise for us is this one. I'd like you to get the coverage and to deliver a proper coverage in my design. So for example, you see I started with a P12. So I can change the height of the P12. So by default, let's put it right in the middle and change the height to 3 meters. I can also change the vertical angles. And you see now, this is how it works in my projects. I can see this P series available. And if I want to visualize the coverage, then I just have to click on this mapping tools. So the mapping tools is this icon. And when I click on it, I will access to frequency one by one, but very much useful for me is to select a broadband and to get the broadband using the dBMIF option. So what is dBMIF? This is only the 2 kilohertz, 8 kilohertz range, which is absolutely related to the frequency range where we control the coverage of our system. And also because this 2K, 8K is related to our perceptions of intelligibility. Okay, so what we used to do when we design the system is to always get this dBMIF just to visualize the coverage of a point source. So let's say in my case, I want to see what happened with this P12. So I just simply click and visualize the coverage. Okay.
It's not an official MIF. It's
Yeah,
not an
no.
official AAC. Yes.
If we look, for example, to the tenders, if we look to technical writers, most of the time what we see is DBA or DBZ. But MIF is a NEXO DB. This is only 2K, 8K. So what you visualize now in the mappings is we have different colors, and the colors are given by the scales on the right side. So you see that the biggest, so the red, the very red colors is about 140 dB peak SPL. So this is the peak SPL, okay? And every time we change the colors, then this is 3 dB less, okay? So for every color change, this is 3 dB less, okay? Makes sense? So if we want, for example, to get this level related to our operation, because when you operate a system on the field, you never play at the peak, okay? For example, if using a digital consoles, you will use your digital consoles and maybe have your master meters at the output of a consoles around minus 10 dBFS or minus 9 or minus 8. So when you mix at minus 10 or minus 9, this is the headroom of the consoles. And the headroom of a console, if you stay digital is also the headroom of a system. So I can simply specify the headroom. So if I want to, for example, have 10 dB headrooms, I will enter 10 dB and run calculation. And you see now that the value has been lowered by 10 dB. Okay. So currently what I visualize here is the coverage of my point source. with 10 dB of headroom using this dBMIF trace. And as you mentioned, Stefan, if I want now to look at official dB like dBA, I can change the broadband and go to dBA, start the coverage, and see and visualize the coverage in dBA. Okay. So exercise for you now. I'd like you to do this projects. So you will use again the theaters, the same theaters that we worked just before. And this is what I would like you to do, guys. So I'd like to get a coverage in the entire audience and to maintain this coverage between plus minus 3 dB. Saying it differently, when I say plus minus 3 dB means 3 different colors on the mappings. So I don't want to visualize more than 3 different colors on the mapping.
On dBA.
Yes, my target will be at minimum 100 dBA. Okay, I want to get this 100 dBA with 6 dB of headroom. Okay, so be careful. I want to keep 6 dB of headroom. And the maximum height for my system is 4 meters. Okay, I cannot go over 4 meters. So let's take around 8 minutes, 5 minutes, just and try to get your speakers on the software and try to put the speakers at a good location and visualize the coverage. Okay, so let's take 5 minutes.
Of course, use the product available on your version, on your software version.
Alors, Paul, you're right. The question is that 100 dB plus minus 3? So it could be 100 dB is the average. So the minimum is 97 and the maximum is 103. Okay, so this is between minus 97 plus 103. You can use as many speakers as you want. If you use a lot of speakers, Stefan will be very happy. But maybe some customers will find a little bit more too much expensive. So you have to find the good balance. Okay, right. So let's see how we can do that very quickly. So I will go back to NS-1. So I will show you. I will take the opportunity to show you some tricks to improve the workflow. So first of all, as you can see on the top of the Windows, you can access to a tools which is called View for Moving Speakers by Mouse. So instead of writing the coordinates of the speakers, I can directly select these options. And you see that just by dragging a speaker, so I will choose a P12 for starting. So if I take the P12 and drag the systems, then you see that my speakers can be moved just inside the software. Okay, so I can put the speakers at the location. Okay, so this is very close to this value. And then once it's finished, I can go back to 3D and see where it's located. So you see by default, I think that the height is 0. So what can I do first is to adjust the height. So adjusting the height can be done by opening the speakers and, for example, set different value. Okay, so let's try, we talk about 4 meters. 4 meters was the maximum, so I can go with 4. And you should see now the aiming of the speakers with the green laser. So if you don't see the green laser, it's because probably in the speaker, in the view menu, show laser beam has not been checked. So make sure that this show laser beam has been checked. Okay. So I need now to adjust the aiming of my speakers. So I can open a speaker position table. So if I click on this icon, I will have on the same page like a summary of my speaker positions and also where it's implemented inside the 3D view. So I will open that window, resize it, okay, and change the vertical angle. So let's try to target, for example, the back of the first audience, okay. So you see that the laser now is going to the good location. And then let's run the prediction. So instead of dBA, I will start dBMIF because I want to focus on the coverage. The headroom is 10 dB. And let's increase a little bit the density of 3 points per octave just to make it more accurate. And start, we visualize. So this is what we get, okay? So you see in dB MIF 2K 8K with 10 dB of headroom, I'm in the targets, okay? Why I'm in the targets? Because I remove so many information from the low that the level now drops a little bit. But if I want to be sure, I can select dBA and look at the coverage. So you see that the maximum is 103. And we have the color of the red colors here, which is about 96. So if I now have a look to the 3 different colors, I can see that it's not possible to reach the back of the room with one point source. Now remember what we explained before, point source is limited with the throw. So don't expect to go to a bigger throw, to such a big throw with only point source. Maybe I can change a little bit the vertical angles and try to focus a little bit deeper. Have a look. Okay, so this is my coverage. And now I can try to do the same on the other side. Okay, so if I want to do the same on the other side, I just have to select my speakers and access to the duplicate speakers icons and select flip across X. So we duplicate my speakers on the other side. So this is the stereo configuration. We have a look and we see now that from that point up to that point, we have 3 different colors, okay? So it means that I will need delay system, okay? So to get the delay system, very quickly, I take this one and I will duplicate this one along the depth. So I will go and select offset value and I will shift these speakers by, let's say, let's try 18 meters. Okay, so I have now the new one. Let's look at the coverage. Seems to be okay. So I just have to duplicate it on the other side. Run prediction. And that's it. All good. So once again, in that case, what you visualize here is dBA. Okay, so if I try to get connected with a tender, the tender was an average of 100 dBA plus minus 3 dB. And you see here that I'm good with a tender. But if I want to have more details on the intelligibility of the systems and to have a better overview of the coverage, it's better to be more restrictive. And instead of running dBA, I will look at dBMIF. And you see when working with dBMIF, now it's very obvious to see that probably we will need more coverage in the front field. Okay, but I will talk about that later. Make sense? Okay, so I carry on. When you have your speakers available, you can start by implementing some delay value. So you can start doing a tuning of a system. So you can start by visualizing if the arrival time from one system to the other is good or not good. So remember when I opened this venue contours, I was able to get the analysis of direct sound, but I can also visualize the time coherency of the main system. So what I recommend when you use the time coherency is always to compare no more than 2 speakers at the same time. If you compare too many speakers at the same time, there are so many arrival time, but it's very difficult just to take the good decisions about the delay. So I'm going to mute all the systems on the right side, on the left side, sorry, and keep only the system on the left. So to mute the system, just open the speaker positions and mute the speakers on the left. So this is P12.12 and P12.3. And then I will run that prediction, and instead of having this direct sound checked, I will select time coherency main and start. And this is how I read this value. So when you get to red, it means that the coherency is right to 1. So it means that the time alignment is perfect. And if you go to cold colors like blue or dark, it means that the alignment is not good. Okay. So in my case, I can see that the alignment in that region is not very good. And the main reason is that if I look at the positions of my P12, I need to implement any delays for the for this one. Okay, so as it's 18 meters from the main system, I can compensate with the delays of 18 meters. Okay, so let's go 18, and then look at time coherency, and you see that it's better, but I can do it better because there is still a zone here where it's not perfectly aligned. So maybe I can go with a lower value. So let's try to move the value, and let's go 17.5. Run prediction again. You see it's better. So let's go 17. Even better. Okay, so 17 meters of delay will be probably the best value that you will implement on site. All good? Stefan, all good for you?
Yes, it seems to be the same for participant.
Okay, so let's carry on. And let's try to work on the project, but instead of using point source, I will try to use line source now. So line source solution, let's quickly summarize. So you can make an array of line source. So this is the main difference. So if you can have a bigger array of line source, then you can provide also higher SPL. So the SPL is bigger. And you also extend the flow of the system. And the main reasons is with a line array, we have not a spherical wavefront, but we have a cylindrical wavefront. So instead of having a drop of -6 dB per doubling distance, then we go to something -3, -4, depending on the shape of the array. So for the application, line array are very good solution for what we call the frontal systems with high SPL providing. But it's also, as it's very directive and you control the directivity, it's also very suitable for difficult acoustic conditions. Okay, so this is quickly why we prefer line source in that case.
Sorry,
Yes.
Nicolas, just to go back to time coherency.
Yes.
of course, it's possible, as you've shown us, to use it for have a line coherency, but is that possible to do it for the complete arena with stereo altogether?
So what I recommend is always to look at the coherency between a main system and a delay system. If you run, for example, your left and right, it's very much the same when you measure delay on the field. You never measure the delays with both left and right running at the same time. The main reason is that the arrival time, there are so many arrival time coming from the different system that it's impossible just to visualize the impulse response on your screen. And this is basically the same in NS-1. So we recommend just to use to be, for example, start with the left and to get the main system left open, then the delay system, and then check the time coherency. If you have a second delay, then mute the first delay and open the second delay and look at the time coherency. But always compare two systems at both of the time. Otherwise, you will see many colors on the screens. It will not be helpful for you taking the decisions.
Thank you.
Okay, so let's have a quick overview of our line source solution. So we have the NEXO Geo M series range. So NEXO Geo M series range starts with a smallest cabinet, which is Geo M6. So as you may see, it's still quite powerful. So 127 peak SPL, and currently the maximum vertical angles is 20 degrees. And we have two options available regarding horizontal coverage. Viscone by default with 80 degrees, but we can get additional flanges at the outputs of the waveguide, and we can switch from 80 degrees to 120 degrees if we want. This is a typical coverage that we use, for example, for downfield cabinets. So we have M6 with different example. We have also M10. So M10 is the same of M6, but instead of having 6 inches, it goes to 10 inches. So we increase the bandwidth. We increase massively the maximum SPL. We go now to 136 peak SPL. The angle available goes to 12 degrees if we use M1012, but we have also a special cabinet that can go up to 25 degrees for downfield application, for example. And horizontals come by default with 80 degrees, but can be changed with 120 degrees by adding additional flanges.
For event application, is very nice to see that you can also stack all those products on the top of the subwoofer, as with M12.
Absolutely. So you're absolutely right, Stefan. Thank you for mentioning that. So remember that everything that you see here can be flown, but also ground stacked. And M12 is basically exactly the same as M10, but instead of having the 10 inches, we go to 12 inches. So you also increase the bandwidth, and you also increase the maximum output level that goes to 140 dB peak SPL. So just to summarize, M6, M10, and 12 is very much similar. When you go to a Starbucks coffee and you order coffees, so you have the small version, the medium versions, and the large versions, and you just have to remember that what you have by expanding from small to large is just to extend the frequency range. So you have a bigger range. You also have a bigger SPL, and you also have a bigger throw, okay? Because the cabinet is also bigger, okay?
The weight is also different for sure.
And the weight also changed, you're absolutely right. We also still have the Geo S series. So Geo S series is mainly used now for installation. It's a very, very powerful, cost-effective, because this is high impedance. So you can use these speakers for many applications, like stadiums, for example. We have a lot of examples using the S12 for application. And we also have the our high-end system, which is the STM. So STM is a modular line array. And so it can fit any situation, starting from very small clubs in stack system, for example, and up to bigger stadiums or arenas. And STM is mainly covered in dedicated webinars that is available. So for, once again, for the exercises, we will not use the STM for the exercise, but we will work on the Geo series. So these are examples of what can be done with our STM versions. So let me now explain how you can play with the cabinets in the software. So I will go back to NS-1. So I will delete my design and start with a line array design. So let's go with, for example, let's go with M10. So now when I drop the M10 inside the project, you see that I can select different options. So we have flown vertically. So if I want the system to be flown, the system also can be stacked if I want to do a ground stack, or I can also use the speaker as a single unit if I need to use the front feed, for example. So I will fly my system. And you see when you fly the systems that now you still keep the GPS tabs available with positions, rotations, and electronics. But when you go to speaker, then you will access to more setups available. So let's say that I will put the speakers at 6 meters, for example. So I can see on the left side that I can change the quantity of speakers. So I can increase the number of speakers if I want. M10-12 is M10, 12, and 12 is 12 degrees maximum of play angles. And M10-25 is for the downfield cabinets. Okay, so we can go up to 25 if we want. Then we have the speaker's angle settings. So I can change the value to create any shape that I want. Okay, so let's do something like that. I can also rotate the speakers. And then you can visualize every aiming and every laser, I would say, wave or every beams starting from the different speakers. So this is what you see on the side view. And on the bottom part of the screen, what you visualize is the pressure plots. So pressure plots is the dB SPL that is provided on the audience area. Okay, so currently what you see is two curves. This curve is the pressure plot for the standing area. So this is the green one. And the red one is the pressure plot for the seated area. So be careful, because when the NS-1 is calculating the pressure plot, he do two calculations, one from this area and one from the other area. And because the size, the height of the listening is different, you can see a drop here, but in reality, there is no drop. This is like, you can interpolate the value from the green to the red, okay? So currently what you see and what you read here is dBMIF. And once again, this dBMIF is very interesting for me. Why? Because dBMIF is related to intelligibility. This is the 2 kilohertz, 8 kilohertz. And the second point is I know that in that range, whatever the size of a line array, I control my coverage, I control the directivity. This can be visible just by doing a right click on the side view and open show SPL contour. So you see, for example, this is your beam. So the sound beam between 2 kilohertz and 8 kilohertz. But if I change this value to 63, then you will see that the wavelength is too big compared to the size of the line array, and I will not be able to control. So this is not very interesting at first step just to get the information coming from the low frequency, because it will disturb my visualization of the coverage. And it's better if I do these restrictions to the frequency bandwidth of 2 kilohertz, 8 kilohertz. And the reasons why we call this dBMIF is because dBMIF is for dB make it flat. So what we want to do is just to get this pressure plot as flat as possible, okay? And how can we get the trace as flat as possible? If I make this play angle very small, then I will increase the level. And if I make this play angle bigger, then I will drop the level, okay? So I just have to look at my pressure plot and try to get this value and to make my trace, my pressure plot as flat as possible. Okay, and this is currently what I'm doing now. So when you're happy with a pressure plot, okay, in dBMIF, then you just go back and you visualize in 3D. So sorry, I need to go back direct sound and visualize. And this is my coverage. Okay.
Still 10 dB headroom, Nicolas.
Yeah, so I will make the exercise a little more difficult later, but it was just to introduce how I can use and set up the system inside. Now, you mentioned also, Stefan, that if you increase the range of a cabinet, we also change the weight of the systems, and we also maybe change the size of the system. So if I click now on the mechanics tab, I will be able to access to this cluster information. So cluster information is the weight. So you see currently that the weight of a cluster is 216 kilograms. You will also get the height. So the height is 2.75 meters. And the rigging point height is 6.15. So 6.15 because it includes also the rigging accessories. So rigging accessories can be changed in the settings part of the Windows. So you see that currently I'm using the touring bumper. Touring bumper is the bumper that I need if I want to fly subwoofer. But as I don't have to fly any subwoofer, I can maybe change to light bumper. And you see, just by changing touring bumper to light bumper, I reduce the weight of my cluster. So I go light. I put extension bar here because currently I fly the system on 1 point, but if I want, I can use 2 rigging points. And if I use 2 rigging points, you see that now I go into red. Why I go into red? Because the gravity center of my points, of the back points, is outside, okay? So as the gravity center is outside of the rigging point, it's not possible to get the value that I specify, which is -5. So maybe I have to remove the extension bar, go on the front, no, and remove it. And you see just by removing the extension bar, that now it's just possible to get the angle. So the left part of the window is just to read the features of the mechanics, so weight, size, angles. The middle part is just to change the rigging mode. And the right part is to check that the safety of my system is okay. So how can I see that the safety is okay? If the value here, which is the working load, still keep below 100%, then it means that the system is safe, okay? And this calculation is done related to steel constructions regulations. So this is a regulation where the TÜV company give and provide certification. So we are certified by TÜV, and whenever you get this value below 100%, then we certify that the system will keep safe.
sorry, two more questions, Nicolas.
Yes.
Could we have more precision about safety factor? What does it mean exactly, please?
So safety factor, for example, you see the value is 4. So what does it mean 4? It means that in reality, if, for example, let's say that you go 100%, so 100% is the maximum value. If we have a 100% that is reached, in reality, it's still safe if you multiply this value by 4. Okay, so this is a kind of headroom of safety. Okay, so it can be 4 times heavier and the system will not break. Okay, so this is the headroom. Depending on the territories, depending on the countries, some countries have very strict regulation, for example, in Germany, and then we'll ask that the system has a safety factor of 4. Some other is 2, but in Germany, for example, is 4.
And second question, thank you, Nicolas. Could you explain again how do we calculate our make it flat MIF?
So MIF is
yeah,
a weighting curve. So MIF is a weighting curve between 2 kilohertz and 8 kilohertz. So we do calculation, and once again, depending on the resolution of the calculation, when you launch this calculation, you can change the density. So the lowest density is 1 point per octave. So you will have one calculation 2 kilohertz, 4 kilohertz, 8 kilohertz. So this is only 3 frequencies. And if you expand and go to 6, these are all the frequencies which are calculated. And then we'll do the summation into this bandwidth. Yes?
Yes, there is another question. To be clear, the image of the speaker's hung is not meant to show the actual number of speakers.
Absolutely. So this is only a JPEG file. Huh? So this is not a dynamic image.
Yeah.
So what you see here is only the example. Okay, so I don't know how much. This is 6, but if you put 8, you will always see the 6.
Yeah, usually 6.
Yeah.
Maybe there is a mistake. I don't know, but it seems for Sébastien that regarding GOS12, we can't put more than 12 box in the new NS-1.
Let me check. So I can show you. If I want to, for example, to exchange one array to the others, I can select one. So I can select my speakers, go to the list, select the new one, do a right click, and then select replace, and then it will be replaced by the new series. So now this is S12.
Yeah, that's very relevant, this tool, to be able to replace when you don't know which product you are going to choose for installation, for integration, for example. It's very convenient.
Yeah, and you can go back if you want. Huh? You see, if I go to replace here, sorry, it's not, it's restore. Okay, if I go to restore, I have a list of all the different speakers, and I can go back and restore the system if I want. So let's try to go more than 12. Okay, so we just have to read, and this is what is specified currently is the maximum of cabinet for S12 is 12. So I can go more than 12. Okay.
It's not related to the bumper, is the way it is.
Let's say it again.
It's not related to the bumper or
No.
the size of the bumper.
See, it's related to the rates of the bumper and all the mechanics. So we are limited in the number of cabinets, maximum number of cabinets that we can have. Okay, so let me show you now. Let me give you some tools, because you see in that case we specify. I put 7 cabinets, 6, 11. So we need maybe to give some rules. Or let's say rule of thumbs to the user so that they can implement their speakers easily. So currently, this is what we have to take care in our design when you run a design. this is related to guidelines. Most of the time, and I'm sure Stefan is the same when you have to specify cabinets for your customers, is how many cabinets do I have to specify for the project? In case of line arrays, so this can be very easy to think. Of course, Stefan, you will say the more cabinets you have, the better it is. But let's have an example. So if I want to provide coverage to this audience, so this is 35 meters depth, and I will do this exercise using two different arrays. So the first one is a line array of 6 M28, and on the other example, I will multiply the number of cabinets by 2. Okay, so I will go to 12. So what does it change if I do a design with 6 M28 and another design with 12 M28? So very obvious, what you change when you increase the number of cabinets is you increase the SPL, okay? You see in average, we have around 111 dB on the audience area. If I multiply by 2, I will increase by 3 dB. So now I go 114, sorry. But by increasing the number of cabinets, I also increase the vertical coverage, okay? You see that the coverage in this example is smaller compared to this one, okay? So increase coverage, increase throw, increase level. What you also increase is the low frequency bump on the array. So this is related to the design of every line array. In line arrays, we have direct radiation driver for the low frequency. So we have a nice, very nice coupling for all the driver inside the line. And we use waveguide, which are highly directive for the HF. So the summation of the low frequency is not the same if we considered low frequency driver and high frequency driver. So if you increase the number of driver, then you will create a bump on the frequency response. This can be a benefit or not. In case of speech, for example, you don't need that bump, okay? What you also increase is the control. So you will get more control on the low frequency just by increasing the number of cabinets. And this is very, once again, very obvious. It's just because the wavelength compared to the size of the cabinets start to be equivalent. So then you can start controlling the bin width, and you also control the near field of the wavefront. Okay, so you have a better flow for low frequency with a bigger line array. So finally, when you combine everything, we used to get this rule of thumb when designing our system at NEXO. When we want to have decent low frequency control on music application, what we used to specify is we take the depth, maximum depth of a venue, and we divide it by 16. And this will give us more or less the length of the array. So to be more practical, this is what we used to specify. So once again, this is the starting point, and not to say that we will do every time, because every case is unique. But we use one box every 3 meters for M6, one box every 4 meters for M28, one box every 5 meters for M10, and one box every 6 meters for M12. And just because the height of the cabinet is bigger, so then the height of the overall line array is bigger. This is for music application, because we need to control the low frequency. If we, for example, go with speech, we don't know, we don't really need this control of the low frequency, so we can maybe have less cabinets, so we can maybe divide the number by 2. If the target of the SPL is sufficient, okay? So let's, you know what, let's try to do it together very quickly on the project. If I keep the same exercise and maybe modify a little bit the tender. So always get the coverage maintained between plus minus 3 dB, so 3 different colors. I want the minimum SPL now is 105 dBA. It's not 100, so it's 105 dBA with 6 dB of headroom. And my the maximum height now is 6 meters, so I can go higher. And there is a weight limitation to 250 kilograms. Okay. So let's try to do it together. So go back to Windows. So I can change, so the value is 6 meters, so I'm good. Let's have a look to the system. So it's not, sorry, it's not S12, this is M12. So I will restore and go to M12.
M10.
M10, sorry, you're right. And remember what we explained before, we said one box for every 5 meters. So if I look at the maximum depth of my system, so this is 30 meters. So 30 divided by 5 is 6. So if I use 6 cabinets, I should be good. Okay. So let's start with 6. So once again, I need to have a look at the pressure plot, dBmIF. So I will increase the progressively the angle value. Okay, and that's it. It's finished. Okay. So I am more or less flat. Maybe I can try, if I do this one, this is too much. If I try to increase, then I can get more coverage. So yes, this is better. If I go C, even better. And I'm good. So I can check in dBA. So this is my value in dBA. I can read the value. So you see on the bottom part of the window, I have some cursor that I can drag, and I just have to read the value in that case. Huh? So 1.8, 1.7, and then it drops a little bit at the end. Okay. And you know what? Let's see the coverage on one side. So 1, 2, 3 colors is good. I will now put the speakers on the left. Okay. Duplicate that speakers on the other side. Okay. And make sure that, because geo is asymmetrical, so make sure that the waveguide keeps inside the venue and not outside the stage, inside the stage and not outside. So I will change it to the right positions and look at the coverage. Okay, and this is the coverage. So you see that with 6 cabinets, I did the job. 10 dB of headroom, I need less, it's what it was 6. Let's have a look to dBA. Okay, so 3 different value, 3 different colors, so I'm good. And if I just want to visualize only on the audience area and remove calculation on the stage, I will just make no audience on the stage, just to avoid the calculation. Run again. And then I can have a brief overview of the statistics of my coverage. So if I click on contours, I will be able to open SPL histograms. And this is my sound pressure level distribution. So currently you can see that 50% of the audience has 103 dBA. Then we have 30% with 106, and the other one is 100, okay? So I'm within the range that I specified just before. Check the mechanics. So I can use the 2 rigging points. Everything is green on the LED. I can maybe try options with one rigging point. So it's also possible to go one rigging point with a light bumpers. And finally, just to summarize, I can look at the equipment list at the end. So we have 10 M12, M10 12 and 2 M10 25. And I can generate a report just by clicking File, Print, and then I will be able to generate these different pages with all the value available. So these are the position, side view, angles, mechanicals, and coverage at the end. And that's it. Do we have any questions, guys? Are there any things that you need to get now?
How do I change the range of pressure, please, Nicolas?
Yeah, so if you want to change the range of pressure, when you run this calculation, you see that you can change the value. So by default, if you do nothing, it will take the highest value and get the highest value as the very red color, the red color for the maximum. If I want to change that, I can specify any value. So for example, if I go to 130 and redo the calculation, you see now that the biggest value is 130 and my biggest value is 106. So I change the colors with this one. Okay, so if I want, I can go 120. Up. And this is how I change the range. Range by default is also automatics. If you want to make it shorter, you can get, for example, 20 dB range of colors. So you will see in that case that we have less resolutions on the calculation. Okay. So what we used to recommend in that case is to always use auto first. And if you want to go more in detail with the color codes, then you can change the value SPL max and range if you want. Do we have our question?
Yeah, there is several ones, so I let you have a look, please, Nicolas.
So will the NS-1 auto-generate the accessory list for geo-online arrays? Unfortunately not, but this is currently in the pipe. Okay, so currently what we generate is only the equipment list, but we are working on making also the accessories available. Autosplay function is not really planned in the future. The reasons for that is, to be honest, autosplay is only good just to give a starting point and the last angle value. So it gives same steps between the angles, but most of the time what you have to do is just have to redo everything by hand just to get the curves that you want. So currently this is not in the pipe, so not to say that this will not be available, but at NEXO we think that just doing by hand goes as fast as doing the autosplay. So the histogram, so we have a question, can you repeat the utility of the histogram? Utility of the histogram is just to make sure that the distribution of the level is within the range. So what we specify for the exercise is we want to have all the audience between -3 and +3 dB range. And this is exactly what you visualize going to histogram. We see that we have 50% of the people that have 103 dB SPL, 30% which they have 106, and 20 they have 100. So 50 plus 30 plus 20 is 100%. So all the people are within the range. Okay, so it's just to make sure that the level distribution is good. So please describe why you flip over X and not over Y. Okay, so why do I flip X? Let me show that. So you see, when I flip this one X, it means I will do the symmetrical along the depth. Remember that X is for the depth, not for the width. So if I flip across Y, you see that now this is from the top, they are back to back. Okay, so this is absolutely not what I want to do. So X is to duplicate left from right, and Y is to duplicate front and back. How can we reduce the rear lobe to stage? So currently, if we look at the coverage on the stage, if we run dBmIF, you can see that the rejection is very good. So the main issue in that case is when you give a low frequency coming into your calculation. So when you run dBA, you can see that running dBA, then we have a low frequency that's coming on the stage. But if you run any subwoofer, this low end will always be masked compared to the subwoofer. So if you want to get no level at the back, you need to run cardio with the subs. Okay, this is the only way of having good rejection on all the frequency range. But once again, when you run dBmIF, you see that the rejection is very good.
Another question, maybe the last, because we are ahead of time. What is shadowing, please?
Okay, let's do that. So we have also a question about density settings. So the density is the accuracy of calculation. So if I increase the density, the software will calculate much more frequencies calculating. So if I use 6 points per octave, more frequencies calculated compared to 1 octave. Shadowing, if for example, let's say I have this one. If I want to, if I create a balcony, so let's do a balcony. So I will increase the value by 3 meters. So I have a balcony. If I run my calculation, then you can see that it seems that I have a lot of level, so it doesn't change anything. The reasons is because I need to check the shadowing. So when you check the shadowing, then every time you have any surface above another one, it will not be able to cross that surface. And this is exactly what I want to do for in the case of a balcony. So if I press shadowing and run the prediction, then I can see the shadow effects here below the balcony. So the right-left option in the GeoM12. So we have also this one. So let's answer that question. When you go with the GeoM series, you see that we have an option which is called radiation direction. So left, what does it mean? It means that when I face the speakers, the HF is on the left side, okay? If I duplicate this one, then you see in that case that by doing the symmetry, the horn is also on the left side. And this will lead to not a symmetrical coverage. So if one driver is on the left, then going on the other system, the driver must be on the right. So I need to change the orientation of the driver and select right in that case. Stefan, is there any words that you would like to say before we conclude?
Take care of you, or take care really of you. I hope it was very interesting for all of you. Please think that we are always reachable with the address technical@nexo.fr. That's it,
FR, yes.
Nicolas? FR,
Right.
yeah. And please free to contact us for any other question, and you're welcome for next session of webinar.
Cool. Christophe, you can speak now. So thank you very much for doing the translation. I don't
Merci
know
à tous. Dis-moi, Nicolas.
I don't know, je sais pas trop comment c'était. Alors, c'est quelque chose que je dois faire dans 2 jours, la traduction. J'imagine que ton cerveau, il doit être un peu épuisé là. I imagine your brain is
Et c'est
Hello.
pas super évident de suivre en direct, mais j'espère que tout le monde a pu suivre les différentes utilisations de NS1. Et n'hésitez pas à nous contacter si vous voulez d'autres précisions sur comment designer des systèmes, notamment sur tout ce qui est schéma d'installation fixe. Hein. Je suis à votre disposition. Comme disait Stéphane, nous avons une adresse mail dédiée à ça. Et on sera très heureux de pouvoir répondre à toutes vos questions et de prendre du temps avec vous pour vraiment vous développer notre logiciel de prédiction qui, je pense, est un très bon outil qui peut être très efficace et très rapide.
Bye bye to everybody. So we keep the questionnaire
Bye bye to
open if
everybody.
you want to finish to fill the question. We will just mute the microphone and turn the camera off. We say bye bye to all of you and see you next
Bye,
time.
take care.
Bye.